In this video, we will learn about solutions. Solution is a mixture of solids in water. For example, if I take water in a beaker and if we try to dissolve salt and sugar in this medium, and after the dissolving process is complete, this is known as a solution. Now, a homogeneous mixture of two or more chemically non-reactive substance is called as solution. Now, in this medium or in this mixture, we can see that there are various components. So, the substances that are mixed to make a solution is called as component. So, in a binary solution, binary means two. So, a solution will have only two components. One component will be a solute and other will be solvent. So, the example in which we saw, we have three components. One is sugar, one is salt, the other one is water itself. Now the components can be divided into two. One is the solvent, that is majority times it will be water. So the medium of dissolution which allows the solute to get dissolved in it to form a solution is called as solvent. And normally it is present in larger proportion compared to a solute. And in liquid solutions, the solvent is liquid, normally water, and water is the universal solvent as we know. Now, second component is the solute. The substance which gets dissolved apparently disappears in the solvent to form the solution is known as a solute. Now we have characteristic of a true solution, how to differentiate it. One is the nature. A true solution is always homogeneous, that is, its properties are same throughout the whole of the solution. So if I dissolve salt in a solution of water, throughout the solution, if I take 50 ml of water and dissolve 5 grams of salt, throughout the solution the salt concentration will be equalized as the time passes, and it is clear and transparent but may or may not be colored. Now if we come to particle size, the solute particles have molecular size which is around 10 to the power minus 7 centimeters or less. The solute particles are not visible even under a very specific microscope or very specialized microscope. Third is the separation. The solute particles will not be able to get separated from the solvent by just mere filtration, but it can be recovered by other physical methods like evaporation. Now if I let this solution of salt get evaporated under sun or under heat, the water, which is the solvent part, will get evaporated. So water vapor will escape and the powdery part which is left behind will be the solute. So by evaporation we can separate solute and solvent. Now coming to the main types of solution, we have aqueous and non-aqueous solution. Aqua means water. Now because of its ease of availability and handling and ability to dissolve a large number of substances, water is generally termed as a solvent or aqueous solvent. So a solution of a substance prepared by dissolving it in water is known as aqueous solution. Now solvents other than water can also be used to make the solution. So such solutions are termed as non-aqueous solvent such as ether, alcohol, carbon disulfide, carbon tetrachloride, ammonia, etc. The solution of a substance prepared by dissolving in a non-aqueous solvent is termed as non-aqueous solution. Now the solutions can again be divided into two types based on the amount of solute dissolved in it. So that is dilute and concentrated solution. So now solution having very low amount of the solute in a solution is known as dilute solution, whereas a solution having large quantity of solute in it is termed as concentrated solution. Now if I dissolve a bit of salt, let's take 5 grams of salt in, let's assume, 100 ml of water. And in comparison, in the other beaker we'll have 100 ml of water, same amount of solvent, but the solute is very high, so we can take around 150 grams of salt. So in this case, we always use it in comparison with the other solution. So if I take A and B, I cannot tell if A is dilute or concentrated alone. We'll have to compare with other sections also or other solutions also. So now here we can tell B is more concentrated compared to A. So A will be a dilute solution and B becomes a concentrated solution. Now we have to distinguish the solutions based on the comparison between the other always. Now that is why we have to remember that this distinction is purely arbitrary, as no definite line can be drawn. So if I imagine and you get another beaker C, and where we again have 100 ml of water, and if I dissolve, let's take 1 gram of salt in it. Now this becomes a dilute solution compared to A. Now A becomes concentrated. Now coming to expressing the concentration. Now we know what is concentrated solution or dilute. How do we express it generally? So the proportion of solute to solvent is given in the solution, or in the given solution is expressed by the concentration of the solution. Thus, the relative amount of solute and solvent present in a solution is known as the concentration. So as we saw earlier, so if I take the water in the given solution is around 100 ml, and then the salt dissolved in the water will be 5 grams. So this concentration can be drawn after knowing each of the concentration. Now there are two main ways to determine the concentration. One is the mass percentage, that is percent by mass. The mass percentage is defined as number of parts by mass, that is the weight of the solute dissolved in 100 parts by mass of the solution. So mathematically how we can write that mass percentage equals mass of solute by mass of solution into 100. Now what is a solution? Solution is mixture of two components, that is solute and solvent. So we can write this formula as mass of percentage equals mass of solute divided by mass of solute plus mass of solvent into 100. So the percent composition by mass or weight of a solution is generally expressed as percent small letter w by capital W. Now if I take an example, now if I calculate the mass percentage of a solution containing 5 grams of glucose to 250 grams of the aqueous solution. Now mass of solute here is very clear, that is 5 grams. So in the numerator we have the 5. And in the denominator we will put 250 because that is the mass of the solution, solute plus solvent, and we'll multiply it by 100, so we get 2%. So concentration of this solution is 2%. Second method is volume percent or percent by volume. Now volume percent is defined as the number of parts by volume of solute dissolved in 100 parts volume of the solution. So in previous we saw the mass of each of the component, and here we will be determining the concentration with respect to volume. Now the formula will be volume percent equals volume of solute by volume of solution into 100. Again solution volume can be bifurcated into volume of solute plus volume of solvent. If we see an example, so if I take a 5% by volume solution of ethanol, and the which is present in water, means that 5 ml of ethanol is present in 100 ml of the solution. So a solution of ethanol containing 10 ml of ethanol dissolved in 250 ml of water. Calculate the concentration of the solution in terms of volume percent. Now first is volume of solute. Solute is what? We have ethanol. So here we will take 10 ml of ethanol, and then we'll have volume of solute plus volume of solvent. So volume of solute is 10 again, but volume of solvent is 2 50. So we will add in the denominator 10 plus 250, which is 260. But if we see in the numerator, we have volume of solute, which is 10 into multiplied by 100, so 1000. Now which gives us 3.85%. So this is the volume concentration of the given solution or volume percentage. I hope this topic is clear to you. Thank you.